Yesterday we have done summing amplifier. Okay, so before we proceed further, let me solve one problem which came last year in 2022. So basically the gain, okay, gain also can be defined in decibel. Okay, decibel also is the unit of gain. Okay, a logarithmic unit, okay, which is most commonly used in amplifier or electronics, because once you use this unit, then calculations become easy when there is a cascades of amplifiers. So last year one problem came 2022. Okay, so in that problem what they said, they have given you a amplifier with a voltage gain of 40 dB. Okay, so they have given you a amplifier, open loop gain is given 40 dB, this time gain is given in dB. Okay, and then what they say that if you give a negative feedback with a fraction of 1/40 connected to the input. Okay, so basically what is the question, they have given you amplifier, okay, not necessarily op amp, but just they give amplifier. Okay, these are the input. So what they are giving in V input, and you're getting some V naught output. Now a fraction of this in this V naught, okay, beta V naught, they are again giving as a negative feedback. Okay, so they're asking now what is the new gain. So we have already solved this one. Okay, we know if it is open gain is 40 dB, then closed loop gain will be what, a upon 1 plus a beta, isn't it? Okay, this open loop gain is I'm writing with a. So for example, if you are giving, you have V output in the beginning, you are getting like this V input. In second case, okay, you will get, because now input is changed by beta V naught. Okay, now if you calculate V naught, okay, a okay, so V naught plus 1 plus a beta equals to a V input. Okay, so V output upon V input will be upon a plus 1 plus a beta. This is your closed loop gain. Okay, so they say the closed loop gain is 40. Okay, and a fraction of this one, fraction also given, they given 1/40. 1/40 is given as a feedback. So this here, this is VF. Okay, so VF is what, VF is your 40 beta V naught, and beta V naught they are given by V naught upon 40. Okay, that means beta value they have given 1/40. So this much fraction, okay, whatever output is coming, that is 1/40 fraction of output. Okay, that is beta value is 1/40 is going as a this input. Okay, so they're asking what is the new gain. Okay, and for that they have given the options. So gain you can calculate like this. Okay, this gain you can calculate by like this. If gain in normal numbers is given, then you can convert into decibel by making it 20 log a. Okay, so this is the formula for gain. Now in question they have given the options. Okay, options are a 40 dB. What is the new gain? It is B is your 37 dB. C is your 29 dB, and D is your 20 dB. Okay, so you need to find out the new gain. So new gain you can find easily. Okay, can I erase this one? Okay, so they have given you open loop gain as 40 dB. Okay, you can do back calculations and you can convert in numbers. So they have given you, this is 40 dB is your in dB. Okay, 40 dB, which will be equals to, okay, 20 AOL in dB. AOL in dB is equals to 40 dB, and that is equals to 20 log 10 AOL in normal units. Okay, numbers. Okay, so this is basically ratio V naught upon V input. So I can find now AOL value of AOL. So value of AOL will be how much? Okay, if I want AOL, so AOL will be simply, okay, log 10 AOL will be simply 20. This is also dB. dB cancel. Okay, so this will be your 40 divided by 20, that is 2. Okay, and your AOL open loop gain AOL will be your 10 power 2. Okay, like you log e power base 2 to 10 power 2, so this become 100. Okay, now you can find the closed loop gain. Closed loop gain will be your A upon 1 plus A beta, or open is A is open loop gain. Okay, AOL. So you have 100 plus 1 upon 100, and this beta is given by 1 by 40. Okay, so this is cancel 2.5, so this become 100 upon 3.5, isn't it? Okay, so how much coming? 100 upon 3.5. 100 upon 3.5. What is the value?
28.57.
28.57. Okay, but this is a number. You are asking answer in this decibel. So you again have to convert this in decibel. So closed loop gain in dB will be 20 log 10 of 28.57. Okay, tell me the answer, and that answer will come in dB. So log 28 is how much?
29.11.
29.11 is coming, na answer. Okay, correct. Okay, so this is C is your correct option. Okay, C is your dB. Okay, clear? So this way, if there is a feedback value is given, you can calculate your new closed loop output. I'm writing one more problem. So basically, what are the foundation of op-amp? Okay, we have already done. What are the skills are required? Now only there will be new application will be there. So fundamental, whatever we learn, that we have to apply. So that will be not now tough. Okay, now will be all be almost similar type of problems. Okay, so this is you have minus plus 4 kilo ohm, 6 volt. Here this is your 4 volt. Okay, this is your, now this time you have 10 kilo ohm, and this is your V naught. So they say find V naught. What is the value of V naught? Okay, so again, it's ideal. Ideal means this is AOL is infinite. Okay, so this is the voltage will be same. This is 4. This will be also 4. Okay, so you can again write equation here. Current I is coming. This current is going here. So what I can write? I can write 6 minus 4 upon 4 kilo ohm equals to 4 minus V naught upon 10 kilo ohm. Cancel. Okay, this becomes how much? This become 2. This become 5. This become 2. So 10. 8 minus, sorry, this 2 to this 2 to 1. So 5 equals to 4 minus V naught. So V naught is equals to what?
-1.
-1. 4 minus 5 -1 volt. Correct. Okay. So this is -1 volt is your answer. Now we have done summing amplifier हमने कर लिया था. Now we will see difference amplifier. How we can do difference. Okay. बता दो इसको. I'm erasing. Okay. So put the adding difference amplifier. So you have been given one op amp minus plus. Okay. So you have been given R3, you given R4. Here you are given a voltage V2. Okay. And here also you have given one resistance at inverting terminal, and that is connected to V1. Okay. And the loop feedback is again RF. Feedback is RF, and this is your V0. This is your R1. This is grounded. Okay. So find the V0. What is V0? Okay. So now in this question, you have both voltage at inverting also you have, and you have voltage at non-inverting also. So better to apply superposition principle and calculate V0, or you find voltage here. What is the voltage here? And then you can do same what we are doing. Applying current. Okay. So let me do this problem. Okay. So if you want, you can find the voltage here. So it is finding voltage is very easy here. If you want to find this is V plus, what is V plus? So V plus is simply what? V2 upon
V2
R3 plus
R4 into
into R4. Okay. So now you know this V plus, this is also V plus. Okay. So you can do this way. You can solve the problem. Okay. By doing what? V1 minus V plus upon R1 and V plus minus V naught upon RF. Okay. And you can find now value of V naught. This is the one way. Okay. Other way is what? Other way you do superposition principle. Okay. So you say how much, what is the values coming? Tell me. So it implies minus V naught RF is equals to V1 upon R1. Okay. Minus V plus upon R1, and here minus V plus upon RF is also going here. Okay. So this will give you V naught equals to minus RF upon R1 V1. Okay, and then plus
1 plus RF by R1.
1 upon R1 plus 1 upon RF, and RF is coming from there, V plus. Okay, this is minus RF upon R1 V1. Okay, so this become what? 1 plus RF upon R1 V plus minus RF upon R1 V
सर बीच
plus
में प्लस होगा.
plus 1 plus RF upon R1. Okay, and V plus value already we calculated, V2 R4 R3 R4. So this is your V output.
सर आपने पिन नहीं किया है क्या?
हाँ
पिन नहीं
स्क्रीन
किया है.
स्क्रीन पिन नहीं है.
ओके, सतीश इसको पिन कर दो.
Yes, sir.
So this is the formula. Okay, now you can do this same problem using superposition principle also. Okay, so in superposition principle, what we do, if I want to calculate effect of this source, I'll make this is 0. Okay, so now here no voltage is there. So if I want to calculate because of this one, so what will come? So say because this source is V01, that will simply inverting amplifier minus
RF by
R1 into V1.
V1.
Okay, now second time I will make this one as a ground, and I will do it this one V2 is acting. Okay, this time my V0 will be simply what?
1 plus RF by R1 into V plus.
Okay, 1 plus RF upon R1, and what is the voltage coming here? That is V plus. Okay, and V plus already we know, RF upon R1, V plus is nothing, that is R4 R3 plus R4 into V2. Okay, and the total voltage will be V01 plus V02. Okay, the same expression you get again. Clear? आगे चले?
Yes.
Okay.
सर ऐसे डिफरेंस एम्पलीफायर क्यों कहते हैं?
हाँ, डिफरेंस क्यों कहते हैं इसको? वेरी गुड. ओके, अभी इसको डिफरेंस क्यों कहते हैं? डिफरेंस क्योंकि नाउ सपोज I have the expression. Okay, this is my answer. Okay, now suppose if I take R1 upon RF equals to R3 upon R4. Okay, if in this expression, say case 1, if I take R1 upon RF, R3 upon equal to R3 upon R4, then what I can write? Okay, then what you can write? Okay, this is V4, so this is minus RF upon R1 V1 plus 1 plus RF upon R1, and you have here V2 R4 upon R3 plus R4. Okay, so you little bit simplify this RF upon R1 V1 plus 1 plus RF upon R1, and then this you have a, you can write this as a 1 upon 1 plus R3 upon R4 V2. Okay, now if this ratio is same, then this will cancel out, isn't it? This will cancel out or not?
Yes, sir.
So what will get? What the value will get? Tell me.
V2 minus V1 into RF by R1.
Yes, 1 minute. Yes. Anything is missing here? Any term is missing here? I'm missing anything or not? Here, something is missing.
कि सर ऊपर एक RF by R1 होना चाहिए।
कहाँ पे? इधर? how that will come?
सर एक मिनट सर।
ये this one already there ना? So when I multiply by 1 by
सॉल्व हो चुका है ना
हाँ?
आरएफ कैलकुलेट, ये सॉल्व हो चुका है सर।
ये सॉल्व हो चुका है।
हाँ जी सर, आपने R3 over R4 लिया।
और अगर मैं R4 by R3 करूँ 1 मिनट, if I take just give me 1 minute। हाँ R3 by R4 लेना है, R3 by R4 लेना है। ये यहाँ तक ठीक है क्या? ये ठीक है, याद रखता हूँ ना। R4 upon R3 upon R5, so this is 1 upon R3 by R4, okay?
सही है।
हाँ सही है। And then is V2, okay? तो what is coming if I solve this one? That is simply ये कैंसिल हो जाएगा, तो आपके पास क्या आएगा? RF upon R1 minus and ये आएगा V2 आएगा, okay? I wanted to write in different way, and if I write this R1 by
सर आपने वो जो R4 कॉमन लिया
ये वाला
तो
R4 में नीचे ले गया हूँ सीधे,
हाँ ठीक है सॉरी,
नीचे ले गया हूँ, ठीक है, okay? So now you let what you do, you just put this is 1, okay? Everything you put 1, then what happens? Okay, then your V output will be what? V output will be, this is V minus V1, and this has become 1 cancel, this become V2. Oh, so you got V2 minus V1, you can understand this way. So this is basically difference amplifier. Okay. And if I take this is R4 by R3, then this will be okay. चले आगे? So basically this is a difference only na. One thing is positive, other thing is negative. So basically depending on the ratio, we are taking their difference only. If this is grounded, you are simply inverting amplifier. If this is grounded, you have simply non-inverting amplifier. If you have voltage in both the place, that means your only output is only some multiplication of difference, and multiplication depends on the resistance available resistance here. If I do this, I can simply calculate V2 minus V1. That is the difference of two voltages. Now, the next problem is instrumentation instrumentational amplifier. Okay, amplifier. ये एक्चुअली कोई टॉपिक नहीं है, इस पे एग्जाम में क्वेश्चन आया था जेस्ट में, सो आई एम कवरिंग दिस एज अ टॉपिक. ओके, so they have given one transistor. Okay, given R1 R2. Okay, and here they have given one more amplifier minus plus that is connected here, and this is connected here. This is your V2. Okay, and here you have this is your V1. Okay, and this is your minus, and this connected here. This is your V01. Okay, forgot. This is R3. This is your R4, and this is your R3, and this voltage is giving, they are giving here. Okay, and again here also one resistance is there, R2, R2, and they are putting one resistance here, R1. Okay, now they're saying find the value of V0. So how can I find V0 value? Tell me. What is the value of V0 in particular case? So I finally we have to take this one. This is my amplifier. Okay, so you see this is your simple inverting amplifier. If I say the output of this one is V01, so this V0 will become input for this one. Okay, now second thing is what? Second thing is what is coming here? What is coming here? Okay, that means what is coming here. So if I know this one, what this output, I call it V02. If I know this voltage, I can know what is the voltage coming here. So I know this voltage coming here, I know this voltage coming here, V0. Okay, I can write the V0. Just check it what I'm saying. Can I write like this? So I want to write now expression for V0. Okay, so V0 can be written so I'm doing this in a simpler way, this problem. Okay, so I want this V0. So I should know what is V plus, I should know what is this inverting amplifier. Okay, so what I can write? I can write V0 is equals to, if I ground this one, I can write simply R2 minus R2 upon R1 V01. Okay, and how much is coming here? Here is coming, this is R2 R1 plus R2, okay, into V02. So plus 1 plus RF upon R1, R2 upon R1, okay, and V plus is your what? This is your R2 R1 plus R2 V02. Tell me, can I write like this? ऐसे लिख सकते हैं क्या?
Yes, sir.
I can write like this one. Okay, now let me simplify it further. If I take R1 plus R2, R1 plus R2 cancel हो जाएगा. So what will get? So this will be equal to what? Minus R2 upon R1. R1 plus R2 will be cancelled. Okay, R2 I'm getting common. This can be written as a V01 minus V02. Okay. Now I want the value of V01 minus V02 in terms of V1 minus V2. Just tell me this expression is clear to you? ये समझ में आ रहा है कैसे लिखा मैंने?
So this is the same expression for the difference amplifier, no?
हाँ. So this is my difference amplifier. Okay. I'm getting something here. I'm getting something here also. Okay. So I return the output in terms of this one. But now this V01, V02, I don't know. Okay. What is the value? I don't know. That depends on this input V1, V2. Okay. That means finally I have to bring this V1, V2 in picture. Isn't it clear? So V1, V2 leke aana hai. Now just say this voltage is say V1 and say this voltage is also V2. Okay. Now you just look at this thing, this path. Okay. Whatever voltage is there, this voltage will go here. Okay. I should write V1 or something else. This V1 and V2. Okay. V1 and V2. So now just see here, this is the negative, here no current is going, I minus is 0. Similarly, if you take here this I minus is 0. Okay, so suppose if any current is flowing in the circuit that is going like this, no current will go, no, there's no path, no division of current will take place. Okay, so if I want to calculate now V01 minus V02, how can I write? Say suppose I current is flowing in the circuit. Okay, so if I want to write I current is flowing in the circuit. Okay, I make so bigger, I don't have space to write. Okay, so if I want to write I in the circuit, okay, so what will be I? So I will be simply my V01 minus V02 divided by
2R3 plus R4.
2R3 plus R4. Okay, and this same current also I can write how? I can also write in terms of I in terms of V1 V2. Okay, so this same current I also can write as a V1 minus V2 upon R4. Okay, this in this path, in this side no current is going. Okay, that means this potential difference between resistance you are getting current. Similarly, this potential difference resistance you are getting same current is same in this path. There's no division. Okay, so from here I can find the relation between V01 and V02 in terms of V1 minus V2. Okay, put the value here and get the answer. Okay, put the value and tell me the answer. सो एग्जाम में क्या था कि एग्जाम में उन्होंने V1 V2 का वैल्यू पूछ लिया था, नंबर में वैल्यू दे दिया था, रेजिस्टेंस दे दी थी और पूछा था आउटपुट क्या है. ओके, सो हम डायरेक्टली एक एक्सप्रेशन निकाल रहे हैं, उसमें जब भी इस तरह का सर्किट देगा हम लोग वैल्यू पुट कर देंगे एंड कैलकुलेट. ओके, सो नाउ आई एम इरेजिंग दिस सर्किट. Okay, one more thing is there. How do I write V1 V2? I'll explain now. Okay, so now suppose you have a circuit like this, say minus plus. Okay, and you're applying just 1 minute. Give me. Okay, now you're applying like this V0, and you're applying some input here, say V input here. Okay, V input here. So what will be the output? Tell me, what will be the output? In this case, what will be the output? Just now I have taken V1, I have taken one is V1, one is V2. So if I give V input here, what will be the value of V output? Tell me.
VI.
VI. Okay, because this voltage and this voltage is same, ideal, and this connected to like this one. So this will V0 become what? V input. That things I have used here. This is called your voltage follower circuit. It's called voltage follower circuit. Okay, so because here RF is 0. Okay, so in general the formula for V output is your 1 plus RF upon R1 upon V input. Okay, now here no RF is there, so if RF is 0, the short circuit. Okay, then V0 become what? V0 becomes simply your V input. Similarly here you say R1 also not there. Also R1 is not there. Here this is RF short circuit 0. R1 is not there. That is R1 is open. Okay, that means if R1 is infinite, then also your V0 equals to V input. Okay, then this is called voltage follower circuit. So writing voltage follower circuit, I have written the voltage in the circuit V1 V2. Just check, just now I have drawn a circuit. Okay, using voltage follower things I have written whatever V input I'm giving, I have written that is coming as a V1 V2. Okay, if this is connected, then whatever voltage come, that will come to output voltage come to here. Okay. So now, if you know this thing, now you can put the value of V01 minus V02 in this expression and tell me what is the V0. Okay, I am writing the final expression. Can I erase this one? Okay. So now your V0 is nothing minus R2 upon R1 V01 minus V02. Okay, and V01 minus here implies so this implies okay, V01 minus V02 is equal to 2R3 plus R4 upon R4 V1 minus V2. Okay, put this value here, minus R2 upon R1. Okay, 2R3 plus R4 upon R4. Okay, V1 minus V2. And this will give you what? Minus R2 upon R1, 1 plus 2 R3 upon R4, V1 minus V2. If you put minus inside, R2 upon R1, 1 plus 2 R3 upon R4, V2 minus V1. This is your V output formula. Okay. Now they have given some value. Okay. You can use this value and directly you can find what is the V output in the question. Okay. आगे चले. This is clear. Vinita,
Yes, sir.
Lakshmi, Radhika.
Yes, sir.
Okay.
Clear, sir.
Okay. So this is your, now put the integrator circuits. Okay. Integrator circuit. Integrator circuit means now your output will be integration of your input. Okay. And this all I'm doing application of inverting amplifier. So you have minus here, you have plus here. Okay. You make this is a ground. Okay. You put same like here a resistance R, and now here you put one capacitor. Okay, this is your V0 capacitor, and I'm saying giving a R, and this is my V input. Okay, so this circuit, okay, V output will be integration of V input. Okay, solve the circuit. Tell me what will come if I solve this one. So ideal, say consider this is ideal. So if it is ideal, this is 0. Automatically, this is 0. Okay. So now current is going like this. Current is going like this. Okay. So what I can write?
कैपेसिटर ऊपर लेना है अब.
हाँ ऊपर लेना है, लूप में लेना है. Okay. So what will be I? So I will be simply a V input minus 0 upon R. Okay. Similarly, you know what is the capacitor current? Capacitor current is what? C equals to dV upon dt. You done earlier, and here dV is what? 0 minus V0 upon dt. Okay. So just put the values there. So you can put here this current here, say IC. Say this current I equal to IC, and IC is what? IC is just this thing, that is C0 minus V0 dt. Okay. So V input upon R is equals to minus C V naught dV by dt. Na? What? dV by dt. So you write as a d V naught upon dt.
D V naught कैसे होगा?
Wait. Here dV. Na? So what I'm saying, this difference is 0 minus V naught. Okay. This final to letter. Okay. So can I write this dv as a minus dv naught? Can I write like this? This is minus c dv naught. Okay. So basically this is the voltage difference, na? Voltage difference from here to here. Okay. This is a voltage difference here to here. So that there's dv I can write as a dv naught because that is 0. Okay, check it. Can I write like this? Or
yes sir. अगर कांस्टेंट नहीं
be
हम assume करेंगे तो
let me explain like this. Okay, whenever you have capacitor, okay, and you're applying voltage like this, okay, and you write current here, okay, then what you write? I equal to C dV upon dt.
CdVt.
Okay, now this time it is opposite way, na? This time I'm taking like this because there 0 is here. This 0 is here. Okay, I'm writing opposite way, so this time I can write minus C dV upon dt. Okay.
yes
So this become, so from here you can calculate your dV naught upon dt equals to minus 1 by RC V input, and your V naught will be minus 1 upon RC, okay, integration V input dt. Okay, so your V output is a simply integral of V input. That's why it is called integrated circuit. Now similarly we can do differential circuit. Differential circuit is same, like no difference, only capacitor will come here, resistance will go there. Okay, and then your output will be differentiation of your input. So do it now, differential circuit. So differential circuit. Okay, you can put here now, capacitor you can put here, resistance you can put here. Okay, so here what I can do, say this is my C. Okay, say this current is IC, say this current is IR. Okay, so IC equals to IR. Okay, IC is the thing. What is IC now this time? C dV input
by
upon
dt.
dt. Okay, and this is what 0 minus V naught upon R. Okay, so simply your V naught become this time minus RC dV input upon dt. So your output is differentiation of V input. That's why this circuit is called differential circuit. Okay, So let us solve one problem on this differential and integrator circuit. I'm erasing this one, okay? So you have been given a differential circuit, okay, minus plus. So you have to identify which is differential circuit, what is integrator circuit. So here is capacitance. They given you V input, okay, and that is all are grounded. The value is 0.2 microfarad. They given you one resistance, okay, of 5 kilo ohm, and then this is your V naught. Okay, they say at t is equal to 0, okay, V naught is 0. At t is equal to 0, V naught is 0, okay, and they are giving you V input. This is your V. They're giving you V input like this as a triangular wave, okay, and this is differentiation. So differentiation of triangular wave will be what? You have to find output. You have to find V output. They given you, this is your 2 minutes, 4 minute, 6 minute, okay, 2, 4, 6, this is 8 minute, okay, and this value is 4. This value is 4, okay. So find out, and this t is in millisecond. The time t is in millisecond. So they say sketch the output. Sketch. What will the output? So output you already know. Output will be what?
Straight line.
Output will be what? Minus RC dV input
By dt.
dt. Okay. Now what is V input? V input is, okay, say for 0 to t, t 0 to 2 millisecond. Okay. What is the slope? What is the value of d input?
2t
Hmm?
0
Two-
0 to 2.
What is slope of this?
2t.
What is slope? Slope is what? Slope is
Two.
what? 4 minus, slope is what?
4 minus
4 minus
2,
0
2.
upon
4
2
minus 0,
millisecond.
2 minus 0.
0. Okay. So this become what? 2000. This 2000 t. Okay, 2000. Slope is 2000. This is y equal to mx equation. So this equation is like this: 2000 t. Okay, 2000 t for this time period. Okay, and if I say between 2 millisecond to 4 millisecond, what is the equation for V input?
Minus 2t
The slope is same.
plus
Huh?
8.
The slope is same. Slope, you can
2008 plus
minus 2000 t plus 8000.
8000.
Yes, 8000. Okay, because now you put 2 here, so this become minus 4000 plus and this plus 4000. Okay, so this become 4000. So no, if you put t equal to 2 millisecond, if you put here, then what will come? So this what 8000 is what? 8000 is what? How this 8000 is satisfying this equation? Okay, how this so how this equation get satisfying?
That t is equal to 4.
Hmm.
V equal to 0, no?
If you put t equal to 4, this 0. Yes, okay. Okay, so this is
V
your this is
equal to
equation.
0.
Hmm. Now find V naught. Okay, so V naught. Okay, V naught in first interval. Okay, and V naught in second interval. So first interval, you have RC. RC is given. R is given 5 kilo ohm. So, or differentiate this one. Okay, differentiate this one. So if you differentiate this one, this will give me 2000. 2000 B input value, dV input upon dt with 2000 for this case and minus 2000 for another case, 2 millisecond to t 4 millisecond. Okay, now put these values here, so you get V output. So V output will be minus, okay, RC is, R is 5 kilo ohm, 5 kilo ohm. Your C is 0.2 microfarad, 10 raised to minus 6. Okay, and this is your 2000. 2000. This is first time period, 0 to t 2 millisecond. Okay, second period you have again minus 5 kilo ohm, 0.2 second into minus 2000. Okay, that is your between 2 millisecond to 4 millisecond. Okay, so this will come what? This will come, this will
-1.
minus 2 volt, minus 1 or 2,
1
माइनस
was.
ये दो हजार भी था, 2 तो आएगा ना, ये 1 हो जाएगा, minus 2
Yes, sir,
volts.
2. -2.
So in this range you get minus 2 volt. So when you have this one you get minus 2 volt, when you have this one you get plus 2 volt, plus 2 volt. Okay, so like this is keep on going. Okay, so whenever you like this you have minus value, and whenever you have like this you have plus value. Okay, so you have differentiation of constant slope. You different, this is on, this is the 80, you differentiate, this become a constant. So okay, then you're getting constant value. Okay, now here minus is there, that's why you're getting minus constant. So this is your answer. Okay, now next class onwards we'll do this your main topic of op-amp, which generally exam questions are asked, that is your frequency dependent gain. Okay, basically filters. Okay, low pass filter, high pass filter, pass band filter. Okay, so we'll do tomorrow filters. So I'm stopping here, 5-minute break is there, and then we'll start your digital electronics. Okay.
Thank you, sir.
Thank you.